Hi, grade nines. So today we're going to start our new unit, which is linear relations. So a couple things we're going to learn and talk about through this course of the unit is how to use expressions and equations to generalize patterns. You're going to be able to verify a pattern using substitution, so basically just checking your answer. You're going to be able to look at graphs and analyze linear relations, and you're going to be able to put information in the graph, and you're also going to be able to take information out of the graph. So to start, we're going to recap and look at a concept that started kind of back in grade 7, maybe even a little before that. Okay, and that is looking at patterns and kind of counting them and figuring out the relationship between two things in the pattern. So it's going to ask you in the question, determine a rule for the number of squares in any figure in this pattern. So what it's actually asking for is it's asking for an equation. It's for you to recognize the pattern and kind of give it this fancy relationship. So in order to do so, we are going to make a table. Okay. Once we have that table is going to actually help us determine an equation. And I will walk you through that. So in figure 1, we have 1, 2, 3 squares. In figure 2, we have 1, 2, 3, 4, 5 squares. In figure 3, we have 7 squares. Okay. We are going to then look at the pattern. So we're going to look at what our number of squares is going up or down by. In this case, our pattern is going up by +2. Well, this +2 actually tells us something for our equation. It's going to tell us what our coefficient is to our variable, which also means what are we going to end up multiplying by. So we're going to end up multiplying by 2. So this is going to be a format for the equation. It's going to be pretty standard. Okay. The A is what you multiply by. That's your coefficient. So in this case, that +2 is going to tell us I'm going to multiply by 2. You can use X and Y, but kind of helps you understand what's going on here. This one tells you figure N in this pattern. So we're going to use the figure to be F and the number of squares to be N. So 2 times, okay, 1 is equal to 2. And then basically the part we don't know is the plus b part. Well, that plus b is what we call our constant because it has no variable beside it. So how we figure this out, you may have learned the whole guess and check method, but there's actually a standard way to go about it, and that is to look back at when your figure is 0. Okay? So at 0. So if you go to figure 0, we can do this. Well, if you're increasing by 2, that means that, well, what number plus 2 equals 3? That's 1. Essentially, you're going plus 2. So this constant is actually 1. So it becomes 2 times f, because that's our variable, plus 1 is equal to n. And if you want, you can actually double check that this works for every single thing. So 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 2 times 3 plus 6, plus 1 is 7. So this right here is our equation. It works for any pattern that we are going to look at in this, any figure that we're going to look at for this pattern. So to check your understanding, if you want to pause the video, try this one out, but we're going to look at another one and kind of get your mind back to this habit of figuring patterns out. So we are going to, once again, use tools. So we are going to make a table. to help us determine the equation, aka the rule for it. So figure, and we're looking at how many squares. So let's make the figure x and the squares y. Kind of make a habit out of x, y that works. So figure 1 has 1 square. Figure 2 has 4 squares. Figure 3 has 7 squares. And figure 4 has 10 squares. Out of good practice, if you just do this automatically, I'm going to go back to figure 0 and know that I have to fill this in. So what is my pattern? What am I going up by? Well, I am going up by 3s. So this 3 should tell me what? It's actually going to tell me my coefficient. Okay, so it's going to tell me what I'm multiplying by. So I'm going to multiply by 3. So 3 times x plus or minus, it could be also a minus, what, in order to get your constant. So, switch. If we're going up by 3s, to figure out your constant, go back 3. So 1 minus 3 should give you negative 2. So this is going to tell us our constant. So 3x minus 2 is equal to y. Okay, so there is our equation, aka our rule for this pattern. Make sure it works. 3 times 1 is 3, minus 2 equals 1. 3 times 2, this is just your own self-check if you want. 6 minus 2 is 4. Okay, good, it works. So then if it was to ask you how many squares in figure 10, in theory, could you draw figure 5, 6, 7, 8, 9, 10? Yeah, but it's going to take you a little while. Or we use our rule, aka our equation. So if we know we're looking for squares in figure 10, just realized squares is spelled wrong. I'm just missing the A. You can actually, okay, figure number is x, so we're going to go 3, and we're going to put the 10 in there. So 3 times 10 minus 2. Well, 3 times 10 is 30. 30 minus 2 is equal to y. So figure 10 would actually have 28 squares. In my world, that's a lot easier than trying to draw figures 5, 6, 7, 8, 9, 10. Okay? So our equation right here, the parts of it, our coefficient, what we're multiplying by, and our constant, what we're adding or subtracting. So if we're going to do another question, we'll look at this second one here. I'm just going to move it up for you. All right. Let me give myself a little room. All right. So to determine an equation, you make a table. I'm going to go figure squares. It's a pretty standard setup. Like I said, make this x, make this guy y. So in figure 1, I have 1, 2, 3, 4. Figure 2, I have 1, 2, 3, 4, 5, 6, 7. In figure 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then knowing to find my constant, I have to go back to figure 0. So we'll deal with that when we get there. So my pattern, what I'm going up by or down by, is going to tell me what I'm multiplying by. So I'm going up by 3s. So this is going to tell me 3 times, this is my x, so 3, whatever my number is, tells me my coefficient. So this is the standard equation. This 3 is always going to go in front. Now, what's the constant? I figure that out by going to figure 0. So I'm going up by 3's. So that means this should be 1. So my constant, because it's a positive one, is going to be plus 1. And there, right now it's an expression. And as soon as I put it equals to y, there's my equation. So this tells me my, right here, this 3 tells me my coefficient. And this guy at figure 0 tells me my constant. This is my constant. This is my coefficient. And you can always leave your x and y as is. And this is a standard expression or equation to use. So just a little understanding. Make sure it helps to understand what your x and y stand for. So x is equal to your figure number in this situation, and y is equal to your number of squares. Okay? And check it. 3 times 1 plus 1, that's what my equation is, does equal 4. Make sure it works for more than 1. 3 times 2 is 6, plus 1 equals 7. Okay, perfect. So, writing equations to describe patterns. What are you going to basically be able to do? Count, make a table, figure the rule out. It does help to kind of recognize what stays the same in the figure, what changes, but the same kind of principle, what we were just doing, applies. I'm just going to move this up here so I have some room. Okay. So, figure number. And we're dealing with squares again. So I'm going to deal with, this is x, this is y. Figure 1, 2, 3. Knowing I have to find figure 0. In figure 1, I have 6 squares. In figure 2, I have 7 squares. Figure, oops, sorry. Let's count. 1, 2, 3, 4, 5, 6, 7. Figure 1, I have squares. In figure 2, I have 8 squares. In figure 3, I have 9 squares. And in figure 0, I would actually end up, once I figured my pattern out, I'm going up by 1s. So to go back to figure 0, this would be 6. My equation, this tells me my coefficient. So this tells me my A. So put that in there. So this is a 1. X plus B. B is my constant, always find from figure 0. This is 6. There is my general rule, aka my equation, with x being my figure number and y being my number of squares. Okay, example 2. So sometimes they don't believe it, you not give it to you in squares, but it's still the same idea. So you have a pattern. Sometimes they'll ask you to sketch the next pattern just to understand it. So if I was to sketch this out, I'm going to say, okay, well, 4 tables, 1, 2, 3, 4. That would mean that I would have person here, 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 and here. 5 tables. 1, 2, 3, 4, 5. How many people? Where would they sit? Okay, so there's my next two table arrangements. What stays the same in each arrangement? Well, what should you notice? Okay, the n people are always going to end up being the same. You're just increasing by 2 people each time. So if we were to make a table for this, I'm going to look at number of tables. Number of chairs or number of people that could actually fit. And this is going to be my X. This is going to be my Y. Okay, so at table number 1, I am counting 1, 2, 3, 4 people. 1, 2, 3, 4. Table 2, I'm counting 1, 2, 3, 4, 5, 6. At table 3, I'm counting 1, 2, 3, 4, 5, 6, 7, 8. And I could use my ones that I drew to also continue this pattern. So figure out the rule, figure out the equation. What are you going up by? You're going up by 2's. That tells me what I'm going to multiply x by. That's my coefficient. My constant comes from me figuring out at 0. So going up by 2's, this should be a plus 2. So y is equal to 2 times 1 plus 2. It does equal 4. So y is equal to 2x plus 2. There is my equation. So different strategies you can determine the number of people. You could notice the pattern, figure it out, go up by 2's and count all the way up till you get to 6 tables and then 10 tables and 25 tables. Great. Or we can use our rule and say, okay, well, if you know this is the case for every single thing. So for 6 tables, I'm going to say that's when x is equal to 6 because 6 is my x is my number of tables. So 2 times 6 plus 2 equals my number of chairs. So 2 times 6 is 12. 12 plus 2 is 14. So I have 14 chairs at table 6 tables. Okay, 10 tables. That's when x would be equal to 10 because x represents my number of tables. So 2 times 10 plus 2. 2 times 10 is 20. 20 plus 2, I have 22 chairs. And if I wanted to figure out even 25 tables, I could keep going even with my chart here. Or I can say, okay, well, y, number of chairs, is equal to 2 times 25 plus 2. So 2 times 25 is 50. 50 plus 2, there should be 52 chairs. All right. Example 3 is more word problem kind of combination. It doesn't necessarily give you a diagram, but they created a table for you. So you actually just have to take out the information. And so because the table is there, you recognize the pattern. What's it going up by or down by? In this case, it's going down. So it's going down by 300 every single time. So we're going to end up multiplying by negative 300. So h is my variable given to me, and time, so this is still x and y if you kind of want to think about it that way. So ax plus b. When they ask you an expression, they're just asking for it without the equals y part. Okay? An equation has an equal sign, an expression does not. So x is equal to your time and minus 300 is your coefficient, so minus 300 times x. What are you plus or minusing by? Well, at 0, there is your constant plus 10,000. There is your expression. So B asks you to write an equation. That means you just now need an equal sign in there. Nothing changes about your expression. We just now say that, well, y, which is actually your height, equals negative 300 times x, which is your time, plus 10,000. Okay. What is the height of the plane after 15 minutes? Well, if we've recognized that we've made x our time, we can now just put that 15 minutes right into our equation. So y is equal to negative 300 times 15 plus 10,000. Negative 300 times 15 is negative 4,500 plus 10,000 equals 5,500 meters. And D, it's asking how long after beginning its descent does the plane land? Okay, so that means I am looking for time. I am looking for when the plane lands. So that means my height is 0. So look at my equation. Now it's not x that I'm given, it's x that I'm looking for in this one, but I'm given y. So when y is equal to 0, we're looking for x. So now our algebra rules apply. I want to get x on my own. Well, I look at my add or subtract and apply the opposite operation. So plus 10,000, I'm going to minus 10,000. And then I still have 300x. That's multiplied by negative 300. And the opposite of multiply is divide. So I need to divide by negative 300 to get x on its own. And x is equal to 33.3 minutes. That's how long it takes for the plane to land. Okay, our last question. Write an equation to represent an oral pattern. So basically, given a word problem, you need to be able to write an equation from it. So if you called Kelly's Cabs, the cost of the ride is shown on the poster in the cab. Here's the poster. Fixed cost is $3.60. Cab rates have went way up than this now, but they usually also charge you for distance traveled. So in this case, they're charging you $1.50 per kilometer. So if we're looking for an expression for the fare, this means that we're looking for that rule to apply what's happening. So it's a fixed cost. So no matter what, as soon as you get in that cab, it's going to cost you $3.06. So that is your constant. It is going to stay the same no matter what. Well, what are you going to end up having to multiply by? It's $1.50 per kilometer. So if x is your kilometer or distance traveled, okay, you have to multiply by $1.50 for every kilometer. So this right here, without the equal sign, is your expression if x is equal to your number of kilometers. So this is A. B, write an equation. So that means, well, y, which is going to be your cost, is $1.50 times the kilometers plus 360 no matter what. So y is equal to the cost. X is your kilometers traveled. And then you have C. Which is asking you what is the fare for an 11-kilometer ride. So $1.50 per kilometer. So my cost is Y, 150 times 11 kilometers, plus no matter what, it charges me $3.60. So 150 times 11 plus 360 should give me $20.10. Now that is a cheap cab ride. And that is the end of 6.1. If you have any questions to that kind of, or something that doesn't make sense, please feel free to reach out and ask any of us. Have a good rest of your day, guys. Bye.